nice sensor from what I discovered. This is the original factory Volkswagen sensor. This is a 10 bar sensor, which should measure up to roughly around 145 PSI. So that should give us a good baseline point of measuring our low side of the field pressure. I'm back on my portable test bench and I'm going through the tedious task of setting up a lot of the wire connections, pinouts for the MOTEC, and hooking up and configuring a lot of the sensors. Very tedious. I've been up for several hours going through a lot of the mapping and planning and staging of what I'm going to do. So I'll try to break this up in stages and explain so far what I have. Tonight, what I've done so far, I have my low field pressure sensor connected, and I'm going to connect that to one of the analog inputs that was not configured in the MOTEC. That goes through something else that is a little tedious, but I'll try to do somewhat of an explanation for that. So on the MOTEC itself, this sensor is not in use, and it's very important that we do have it in use. On the original GM configuration, this was not utilized, but I want to pretty much set up our direct as well as port fill injection system similar or pretty much better than what it was. Better is a strong word, but I would say from our aspect and from a goal, a performance goal orientation, I would say better in that aspect than what is set up from the factory. So I am by no means trying to compare what I'm doing to the factory, but I want to map out and use a lot of the great strategies that the factory used for fuel pump control and modulation of the direct injection system. But we had the addition of a port fill injection that would make our system a lot more better for our application and performance orientation. This was not in use for the system. By this not being in use, this takes away from a lot of other resources that are available for setting up maps and reference to our field pressure. This particular table itself, or the architecture for the package that we have for the direct injection, is broken down in a couple good, I'll say good ways. And once we start playing around with it, then you can kind of understand the baseline. Anything that pretty much says field pressure direct, that is all set up for the direct injection system itself. When you see field pressure sensor, that is our low pressure side, and those perimeters pretty much are set for our lift pumps, which is the in-tank pump that feeds the low pressure system, feeds our fuel rail for our stage port injection. This has not been enabled, so what we need to do is enable it, and what I'm going to do is assign it to analog voltage input 11. Once I assign that to input 11, as you can look down at these windows right here, this table, this should give me extra resources, bingo, available, so that we can pretty much set up a lot of parameters for our low field pressure system. And this will be great. We can set up tables, PID tables, or anything like that as far as controlling the fuel pump. If we lose fuel pressure, shutting down the engine, a lot of different settings, as you see, just to drop down. So that is awesome right there. I need to say that. But that is one of the primary things that I wanted to initially get set up for the low pressure system. My full fuel pump controller, this is basically set up to control our fuel pumps in two stages. We have our remote one for the primary fuel pump and remote two. These are for our secondary fuel pumps. And the remote one, which our primary fuel pump, that flows roughly around 250 milliliters per hour. The remote two, these are pumps 2 and 3. These are 500 milliliters per hour. Now we can always upgrade individual pumps on this setup, the way it's set up, I can actually increase the remote one to a 500 milliliter per hour pump also, or take these up to 750 or even higher. But for the moment, that's basically what we're starting off with. But one of the things that I want to kind of set up a little bit different,
Video out, man. Like, comment, subscribe.